Hey there kids, welcome to another math video. This is Module 5, Lesson 17, Homework. And so as we are getting ready to kind of finish up this module, we're starting to talk about all the different attributes that shapes have. And so here you're going to make a shape. Now, it starts out with just this angle here, and it says, extend the rays of angle A and draw parallelogram ABCD. So you can make it really any size you want. You can extend this out. You can go all the way up to here. If you bring it down, you might run out of room. If you want to stop shorter, you can also go down this way. If you wanted to make something that was a little bit longer, that's fine. And then you'd have to bring it back. This would be a nice little parallelogram here. So you have lots of options, okay? But either way, if you make one that looks more like a rhombus or if you make one that looks more like a parallelogram, it's really up to you. I'm just going to keep my original one here and leave these points at A, B, C, D. So now we're going to talk about the properties of this parallelogram that we just made. Yours can look different again, but the properties will be the same. So what are the measures of angle B, angle C, angle D? So first of all, you have to put your letters, and they usually go in a circle or kind of on your way around the shape. So A, B, C, D would be the appropriate way to label that. And so I just laid out, they give you angle A, that's right here. Don't forget to read that part. But what are the properties of these shapes where you don't really even need a protractor to measure? You can just mathematically calculate it. So here we have our 60 degrees, okay, for this angle here. And so a property of a parallelogram is that opposite angles are equal. So if A is 60, then the one opposite it must also be 60. Okay, so that is what you can put down for angle C. Now, how about angle B and angle D? So one of the other things that we were working on recently was to identify, we'll just flip back for a quick second, angles that add up to 180 degrees. And so those are going to be adjacent angles or right next to each other. So this was from the classwork, and you have to, if you use a protractor to make your own shape here, mathematically, if you get one, then you can take the 180 and subtract that to get the other one instead of measuring it. But since we already have our 60 here, and we're going to show that these two angles should add up to 180 degrees, mathematically, you can solve it without a protractor by doing 180, which is what they should be, minus what you know in order to get the difference. So then angle B would be 120 degrees, and therefore the opposite angle would also be 120 degrees. Okay? So I hope you guys understand that concept. It's something you should know, and then you could write it down on a test or describe the shapes and say, hey, this is an attribute that parallelograms have. And if they tell you it's a parallelogram or that you've made a parallelogram, it has to have those attributes. Okay, and in the same way, if this was 120, just to finish this off, these two would also add up to 180. These two would also add up to 180 because parallelograms are symmetrical like that. Okay, now let's move on to the next one, number 2. WXYZ is a parallelogram. So great, it's got a lot of properties that we can just know because of the name. They're also telling you it's not drawn to scale. What does that mean? That means that if I was to take my centimeter ruler, and it says that line segment WZ is 6 centimeters. Well, it's not actually 6 centimeters. It's the scale is not right. But what they're saying is, it doesn't matter. You don't have a tool. Just trust us. We want this one to pretend that it's 6. We want this one to pretend that it's 3. So it's not drawn to scale. Just trust the numbers and apply the attributes. So we're going to go ahead with that and solve all these questions based on the attributes. Fancy word, attributes. It just means special properties of this figure. So using what you know about parallelograms, give the measure of sides xy and yz. So xy is this side, and so what you do is you look at the length of the side and you try to find the matching one. Well, in a parallelogram, we have opposite sides that are equal. Do you see where it's equal? Yes, right over here, 6 centimeters. So line segment xy, and you could write it, you might see something like this, line segment xy is equal to 6 centimeters. Okay, and then how about yz? That's the short side. Again, look at the opposite, label it, and then you could say line segment yz is equal to 3 centimeters. Okay, and now moving on to the angles. Angle WXY. So it's helpful if you use a colored pencil or something to mark what they're talking about. Okay, so if you look, for example, at angle WXY, and they tell you it's this one here, okay, that's the outer angle, and try to remember that in the middle, that's the vertex point for both rays to be extended. So this is the center right there. And so the total of this is 113 degrees. Now you don't need any tools. You don't need a protractor. Okay, hooray, that's exciting. You can do this with just using the math that you know. So if angle WXY is 113 degrees, that means this whole thing is 113. It's appropriate because it's obtuse. It should be greater than 90, so that's bigger than 90. That makes sense. Now use what you know about the angles in a parallelogram to find the measure of the other angles. Okay, well, if this is 113, then what's XYZ? XYZ. So using a different color, identify what angle are we talking about? We're talking about this whole angle. Okay, so using the attributes or the properties of the parallelogram, knowing that adjacent angles will add up to what? 180. Take away the neighboring amount. Okay, 113. You have to do a little bit of subtraction. No problem that there's nothing here. Take 1, give 10. 10 minus 3, 7 minus 1, and then 1 minus 1 is nothing, and so we have our 67 degrees for this acute angle. So angle XYZ, 67 degrees. And then opposite angles, if they say angle YZW, YZW, that's all the way over here, and that is also going to match the opposite angle. So just look back at what they tell you. If WXY is 113, then this whole angle here has to be 113. YZW is opposite and 113. The last one, angle ZWX. ZWX. Get that green. And look at how it's opposite of this one, XYZ. It's opposite XYZ. Therefore, you don't even have to do any more math. It will be the same as this one. If that's 67 over here, then this one is 67. Okay, so it's a property you can count on. Next up, we have Jack measured some segments in problem 2. He found that line segment WY equals 8 centimeters. So WY, that's this diagonal, okay, equals 8 centimeters. And line segment MZ is your center point to Z equals 3. Give the lengths of the following segments. So now we have point M in addition to the W, X, Y, Z on the outside points. So knowing what you know about your diagonals, that is going to help you solve what we know as the whole or half length so that we can label each individual part. Give the lengths of the following segments. WM. So if we know the whole length between W and Y is 8, then what is the length between W and M? And you would say it's what? 4 centimeters because it's half. Right here, it's half the total. 4 plus 4 is 8. 8 is given, 4 on each side. The diagonals will bisect each other directly in the middle of each of them. Okay, now we'll talk about other attributes in a minute. Does this one look the same length as this one? I hope you say, no, it doesn't. This one looks longer because the parallelogram is leaning. It does have farther to travel, going this long way, as opposed to the short to the short. Okay, so the length of the diagonal, if we're looking at MZ, this here is 3 centimeters. Okay, and again, not to scale, let's call this 3 centimeters. If this side is 3, then this side is 3. And the two of them together would make what? Sorry, I'm getting ahead of myself. I'm so excited, let's just label it all. So going back to the problem for the bottom, WM is 4, that's here. So MY is 4, we labeled it already. And then XM, that's 3. And then XZ, that's the whole distance, and you take your 3 from here and your 3 from here and you add them up. And so the properties of the parallelogram are helping you determine what these numbers are, okay? And you hardly have to do any math at all. It's just looking and thinking. All right, nice job. Keep it up. Here we go. Using the properties of shapes, explain why all parallelograms are trapezoids. Okay, I really love, if you look at, mine has the facing page, I don't know what your book looks like. I love these hierarchy of the quadrilateral hierarchy with parallelograms, trapezoids, and quadrilaterals. This is really handy to help you understand, really lock in your understanding of which one is which and why. So a quadrilateral is the most general name for a 4-sided figure. Okay, it just has 4 sides. Okay, literally quad means 4, lat means side. Okay, and so notice that they gave you a great example here of a quadrilateral that is not a parallelogram because not all quadrilaterals are. Inside of that, you have a trapezoid with it's a regular trapezoid, which it seems to be almost isosceles, not quite perfect, but this trapezoid has still a pair of parallel sides. And that is what makes a trapezoid a trapezoid. It's a 4-sided figure with 1 pair of parallel sides, or at least 1 pair of parallel sides. Okay, so we're looking for 1 pair. And a pair being like a pair of shoes, you have to have 2 of them in order to make the pair. Further in, we'll finish that off, P-R-A-L-L-E-L, parallel sides. Further inside that, we have the parallelograms. Now, the attributes of a parallelogram is that it has to have 2 pairs of parallel sides. So if this is 1 pair with the left and the right, then the other pair is the top and the bottom. And this green is parallel to this green, and the yellow is parallel to the yellow. So the trapezoid only is required to have 1 pair, but the parallelogram is required to have 2 pairs of parallel sides. Now, why am I doing this right now when I'm supposed to be doing the homework for lesson 17? Because you can use this page to help you with your attributes when you explain, you're supposed to write an explanation. So using the properties that I was just showing you of shapes, explain why all parallelograms are trapezoids. So parallelograms, long word, have two pairs of parallel sides. Okay, so if they have two pairs of parallel sides, trapezoids only need one pair of parallel sides. Okay, and so you can't get to 2 without going past 1. You can't have 2 pairs of parallel sides without having at least 1 pair of parallel sides. So that's why that hierarchy works so well, because as you narrow down your description and make it kind of smaller and more specific, it becomes a better visual and you can really see what's happening. So parallelograms have to have 2 pairs of parallel sides, and trapezoids only need 1 pair of parallel sides. And you'll get past 1 in order to get to the 2. Okay, last one. Teresa says that because the diagonals of a parallelogram bisect each other, if one diagonal is 4.2 centimeters, the other diagonal must be half that length. Okay, great. That works sometimes. Use words and pictures to explain Teresa's error. All right, so we've made some really nice shapes on the previous side. I'm going to make 2 more. If you have a protractor or a ruler, you can use either one to make these shapes. First of all, it's nice to have say a rectangle. So I'm just going to draw a long line on each one, and then I'm going to use my perpendicular lines to make a squared off corner. I'm just going to have a really standard regular rectangle here with 2 long sides and 2 short sides. Take off the extras if it bothers you. It bothers me only a wee bit sometimes. And so we're talking about diagonals. So take your ruler or protractor, move all your things out of the way so you can make those diagonals. And again, corner to corner, and try to be precise. And this is what Teresa is talking about. Teresa is saying because the diagonals of a parallelogram, this is a parallelogram, right? What's a better name for this shape, though? It's a rectangle. Okay, and so she's saying that because the diagonals of a parallelogram bisect each other, if one diagonal is 4.2, and let's say this isn't to scale, then the other diagonal must be half that length. And so if she's saying if this diagonal going all the way across, then the other one would be half. So if it's 4.2 all the way across, then the half of it would be 2.1. And so that is what she's saying for a rectangle parallelogram. Works great. Now let's make another parallelogram. And I'm going to keep the lights on. Ha-ha! Like magic. Okay? And we'll make... Ooh, I should have used my protractor. Ooh, now I'm going to be super challenged. All right. I made that long enough, and we'll try our best. We'll close this off. Okay, so let's take this. I feel like it's more like a rhombus. Okay, which is also a parallelogram. Anyhow, making the diagonal here should be pretty clear that our diagonals are not going to be matching, okay? So 4.2, if the whole thing is 4.2, okay, for the whole thing, then half of it would be 2.1. if this little section is 4.2, then this section is 4.2, and this section is 4.2, and this section is 4.2. When you have a rectangle or a square, you're going to have these symmetrical diagonals. However, this parallelogram here does not have matching diagonals. And so if we label this one 4.2, okay, again, like the whole thing, I could have a 2.1 on this side and a 2.1 on here, but that is certainly not going to be the case on these short sides. Okay, so these pictures explain the error, but you could also write a little bit. You must have, and click subscribe. Come back again. I hope I am helpful to you with your problem sets and homework. You must have 4 right angles or 4 sides the same length to have diagonals that are matching, half, duplicated, depending on how it's labeled. Symmetrical, matrical, or matching. There you go. Okay, so you've got to have either a square or a rectangle or a rhombus with equal sides in order to have these diagonals. If they're not, if it's a parallelogram like this, you're going to have a long diagonal and then a short one, and those would not be symmetrical or matching in any way. Okay, so this is not going to be half of this. It would just totally vary. So anyway, I hope this is helpful. I hope you guys are understanding it because I know these are pretty tough. So come back again and we'll see you on another video. Bye for now.